we'll be doing some workshop questions on Play with Graph so that your understanding about a topic is complete. Let's start with easier questions, then move on to the tougher ones. So if you remember quickly, you did some transformations in Play with Graph. What I'm going to tell you is I'm going to give you some questions involving functions, of course. Now, the fact of the matter is these questions can be done in many different ways. You can use formulas, you can use substitution, you can use Humpty different ways to do this question. But what my point here is that if I use the method of graphs, if I use transformation, doing these questions become easiest, right? See, as you may have heard in many of our lectures, it's finally the way you look at the question. A question can be looked in variables in the form of functions. It can be looked in numbers. It can be looked geometrically, which is basically case of breaking it down, visualizing it, and finally it can be looked at graphs, graphical way. So what we are going to do in this chapter is we will look at questions which ideally should be looked in a graphical manner, so that doing it will be easiest. See, the point I'm trying to say is any question, most of this question can be done in more than two ways. A successful student who cracks the question faster is one who recognizes which is the best. When I say best, which is the easiest, fastest, simplest method to do a question. Which way should I picturize it, right? Okay, let's move on to Play with Graph. Question number 1. I am giving you a function x square minus 1, the greatest modulus of which is given, equal to 6x. Question is, how many solutions are there for this particular expression? So how do you do this question? Simply put, the best way to do this question is to draw graphs. So how do you start? Let's start from the LHS side of it. I am basically talking about a function x square to which I am adding a few more things. So let's start with x square. How does the graph of x square look like? X square graph is something like this, right? Is something like this. Then I'm not working with x square, I'm rather working with x square minus 1. So what happens in this graph when I'm talking about x square minus 1? My x square minus 1 is nothing but a translation from x square. What is getting translated? You remember the first transformation we did, right? We said translation is nothing but adding or subtracting a number. It can be to the x coordinate or to the y coordinate. Here actually you are subtracting to what? You are subtracting, you are actually adding to the y of it, because y is equal to x square, and then you are adding 1 to y by making it y plus 1 or x square minus 1. So when you are transposing y by adding a value, what happens to your graph? It comes down, right? It basically moves down by 1 point, and this is your x square minus 1 graph. The point here will be 1. But that's not it, right? You're not really talking about that. What you're talking about is actually another function wherein you're putting a modulus around it. What will happen if I put a modulus around this function, x square? It is nothing but folding the graph. The negative side of the graph will get folded and will go up. So it will look something like this. All this part will be same. Here it will just fold up. So this will be your x square minus 1, greatest integer of it. X square minus 1, greatest integer of it. So if I just summarize the entire thing, your graph x square minus greatest integer of x square minus 1 will be something like this. What about your graph 6x? So this is your greatest integer of x square minus 1. What about y is equal to 6x? The graph of y is equal to 6x will be like this. So how many points are there where they intersect? There are 2 points, or in other words, there are 2 solutions to the question. Clear? Yes. What did I do? Rather than actually trying to solve it by using multiple cases. What will be the cases here? If you want to solve this question, you have to write greatest in modulus of x square function in the more rationalistic format. That is, take it as plus x square minus 1 and minus x square minus of x square minus 1 equated to 6. All these things you will have to do. Okay. Now in this case, what I did is I simply figured out what is the function type of x square minus 1. X square minus 1 also I don't know directly how it is. So I drew a function which I knew, that is x square, transformed it twice to get x greatest integer of x square minus 1, and then figured out how many solutions are there. So that's your question number 1. As you can see, by using transformation, I was able to do the questions quite easily. Question number 2. The question is, I have a graph which I need to find for this function y is equal to 1 by modulus of x plus 1. I've been given 4 options here. Option A, something like this. Option B, something like this. Option C, and option D is something like this. The question is to find the answer for which particular answer option represent this function here. Okay, so how will you get to this? As you can see, it's a graphical problem. The best way to solve this problem should be by using a graph itself. So let's try to figure out how the graph of this function will look like. To get to this function, it's obviously something which we don't know. So let's start with something which you know. That is y is equal to 1 by x. If I draw y is equal to 1 by x, how will the graph look like? Yeah, that you know already. You have seen it. The curve is an asymptote. This is your 1 by x. Now what you're exactly looking at is not 1 by x. What you're looking at is modulus of 1 by modulus of x plus 1. So let's do the first transformation, that is making 1 by x into 1 by x plus 1. So what will happen here? What transformation are you doing? You're adding 1 to x. In other words, you're translating x. When you add plus 1 and translate x, what happens? Yeah, the curve moves 1 unit to the negative x-axis. Absolutely right. So the curve will become something like this. The curve will become something like this. This is your modulus of x minus 1. So earlier the 0 was at this point. 0 was the center of gravity. Now the point about which the asymptote will lie will be y is equal to minus 1. Y is equal to minus 1. But still you are not really looking at this, right? You are rather looking at 1 by modulus of x plus 1. How will this look like? See, modulus of x, I told you, if you're doing a modulus of a function, that is f of modulus x, what will you do? Yeah, you simply will reflect the function about the y-axis. That means everything which was on the negative side of y just disappears. Only thing which exists is the positive side of y. Will be the positive side of y, and on the negative side, the reflection of the same comes in. Reflection of the same comes in. So this is what your modulus of x minus 1 is. That is why your answer option will be C. Right? That's all it is. So please remember the transformation and nothing else. What are the transformation I did? You add or subtract terms to x, it gets translated. Similarly to y, it gets translated, but the translation is about y-axis. Earlier it was about x-axis. Second was you multiply terms to y or x, the graph will shrink or expand. And you multiply to y or divide to y, the graph will get magnified or miniaturized. Right? It was if you do a modulus of it, it gets reflected. If you do a negative of x or negative of y, what happens? It gets flipped. So these were the simple transformation we learned. So I was just using it and nothing else, right? So I had used the transformation of translation here, and here I have used the transformation of reflection. Next question, again a question based which can be easily done if you use transformation. You are asked to plot the graph of y is equal to minus of fraction of a function, minus of x. What does this symbol mean? The symbol just means that if you are given a symbol like this, it just means x minus greatest integer of x, known as the factor of the factorial, factor of the greatest integer function. You already see this transformation. If I apply this transformation, what happens? The function becomes periodic in nature, with the value repeating itself after every interval of thing, and the range of this function lies between the interval 0 to 1. So what you do is you start as normal, a function which you know is y is equal to y is equal to flower bracket of x. Now the graph of this function is something like this. The graph of this function is something like this. Now this is about, but this is not the function you are interested in, right? You are actually interested in two more negative signs. So first let's do one negative sign. So I transform this into y is equal to factor of the function of minus x. So what happens when you transform x to minus x? What is really happening there? You are basically flipping it about the y-axis. So what will happen to your function? Your function, which was earlier inclined toward the positive x-axis, now will get inclined in the other direction. Inclined in the other direction. Now what are you doing? Now you are adding one more negative sign, but the negative sign is to the entire function or to the y part of it. So the function again flips, but this time the flip is about the x-axis. So it becomes something like this. Become something like this. So your answer to the question is the last figure. So as you can see, what I did was very simple, two transformations. I knew if I change x to minus x, you're basically flipping it about y-axis, and if I change y to minus y, you're flipping it about x-axis. Next question. The question is you are again asked to plot the graph here. I am giving you a function here which is y is equal to modulus of x square plus 2 times modulus of x minus 3, and for the entire function I am again doing a modulus, right? So this has to be plotted. Again, use the same thing, use the transformation idea. So start with a function you know. So let me start with this function y is equal to x square plus 2x minus 3. You know this function very well, so you can easily draw this function. If I simplify this, or if I factorize this, I'll get x minus 3, sorry, x plus 3 and x minus 1, right? This is the function. If I try to draw it on an xy plane, the function will look something like this. The solutions are x is equal to 1 and x is equal to minus 3. So I have 1 point here and 1 point here. The curve is a parabola. This is my x square plus 2x minus 3. Then what am I doing? Then I am converting all x's into modulus of x. So my after my transformation, the function will be looking something like this. Y is equal to modulus of x square plus 2 times modulus of x minus 3. So what will happen if you do a modulus of x here? If you do a modulus of x, all terms of, so if you do this, what will happen? It is nothing but reflection about, if you do a modulus, this is nothing but reflection about the y-axis, right? Reflection about the y-axis. So this part of positive x remains there. The other parts, all these things will disappear. Only thing is, the same thing will get reflected to the other side. So this is your modulus of x square plus 2x minus 3. But that's not where you want, right? You're not going to stop there. You're going to do one more transformation and make it modulus of x square plus 2 times modulus of x minus 3. What is happening here? This is nothing but reflection about the absolute x-axis. Reflection about x-axis, or the folding part which we are talking about. So this part will disappear. It will go up. And this will remain there. This will remain there. So this is how your graph will look like. You are supposed to do the graph for y is equal to greatest integer of e raised to greatest integer of x. Again, not a straightforward question. So you start with a simpler question, y is equal to e raised to x. Y is equal to e raised to x will look somewhat like this. And this point will be your 1, correct? This point will be your 1. At 0, it will touch at 1. At 1, it will touch at, the point will be e raised to 1, so on. What will you do next? First, do the first transformation, that is converting this into e raised to greatest integer of x. When you do the transformation of greatest integer of x, you know already what happens. The function the function will become step. That is, for all the values of 0, between 0 to 1, actually you will take the value corresponding to 0. For all the values from 1 to 2, you will take value corresponding to 1. So your figure will be something like this. This will be your curve. So you can see that corresponding to 1, the curve value is The corresponding to 0, the curve value is 1, corresponding to 1, the curve value is e, corresponding to 2, the curve value is e square, and so on. So this is how your graph will look like, right? No, but that's not what you want, right? What you want is one more transformation and make it y is equal to greatest integer of e raised to greatest integer of x. So here you are not transforming x again, you are transforming the entire f of x, right? When you're transforming entire f of x, what happens? These terms which you see, this 1, e and e square, they will go to their greatest integer value. So it's easy now. What will you do? What is greatest integer of 1? You know it's 1. What is greatest integer of 2? You know it's 2. What is greatest integer of e square? The value will be somewhat like 7 point something. So it will be 7. So the curve will transform to something like this. Between 0 to 1, it will remain 1. Between 1 to 2, instead of e, it will now go to 2. Between 2 and 3, instead of e square, it will now go to 7. So this is how your curve will look like. You are asked to do this. That is, I am telling, take the fraction of the function of y is equal to x square but not the y side of it. Quite simple. You know that range of this function, that is the values of y, should always lie between, should always lie between 0 and 1. Should always lie between 0 and 1. So start with y is equal to x square. This is y is equal to x square. Now the point what we told earlier is the range of this function should always be between 0 to 1. Just use that. Here whatever is exceeding the values after 1 and after 0, you should not consider it. So the function between 0 to 1 will be the value you are looking at. That's all. So answer will be this blue part which is curved. This will be the curve of the function. Next question. 1 minus cos 4x is equal to 2 by 3. Question is, how many solutions exist for this function? 1, 2, 4, and none of these. How will you do this question? 1 minus 4 looks boring, so or looks complicated. Let's make it a simpler one-term trigonometric function. So I bring the 2 here. It becomes 1 minus 4x by 2 is equal to 1 by 3. This becomes 2 sine square 2x. You know why? 1 minus cos theta is equal to 2 sine square theta by 2. This is equal to 1 by 3. So I'm talking about sine square 2x is equal to 1 by 3. How will the graph of sine square 2x look like? Let's start from sine x. If I talk about sine x between minus pi to plus pi, this is how the function is. But I'm not really looking at sine x. I'm looking at sine 2x. If I move from sine 2x sec x to sine 2x, that is transform sine x to sine 2x, how will it look like? Sine 2x moves double fast as sine x. So the curve will be like this. and like this. This is your sine 2x. But that's also not over, right? You have to square it. So it becomes sine square 2x. How will that curve look like? It will be like this. Okay? And where will your 1 by 3 be? Your 1 by 3 will be somewhere here, right? So if I look at the points of intersection, I get 1 point here, I get 1 point here, 3rd here, 4th here, 5th here, 6th here, 7th here, 8th here. So answer is none of these. There will be 8 points of intersection, so 8 solution to this particular question. Let's look at another interesting question. This question is called as the graph of candles, and is a pattern which has got huge application in investment, in bank, in stocks and investment analysis and all. So the question is something like this: greatest integer of y is equal to sine x, and you have a second function y is equal to x. My question is, how many points of intersection are there? The graph of candles comes out of this question. Okay, so first of all, let's plot y is equal to, greatest integer of y is equal to sine x. Sine x, you know, is a function of this sort, right? When I'm talking about making y greatest integer, y value can only be integers. When are the y values integers in this case? You have one here, you have one here, you have one here, you have one here, and you have one here, right? So when I'm talking about this particular function here, that is greatest integer of y is equal to sine x, only these integer terms remains. Remaining everything goes off. So this is what your function greatest integer of y is equal to sine x is. It happens at the points 0, pi by 4, sorry, pi by 2, pi, minus pi by 2, and minus pi. And what about your y is equal to x? Y is equal to x is a function which goes like this. And this is your curve y is equal to x. Now the question is, okay, before considering y is equal to x, we need to consider one more case. See, think about it. When I'm talking about greatest integer of y is equal to sine x, one part is looking at these points. These are the only points which y can take. But y can take this point 1 when y is a value between 1 and 1.99999, right? Any value. So if I put a value of y between 1 and a value just below 2, y will always take the value 1. That means when I'm talking about sine pi by 2, it is not only y, it can take all the values from y to all the values from 1 to 1.999. So actually this point you can take all these values. Similarly here you can take all the values till 1. Here you can take all the values till here. The same is the case here and here. Okay, so the graph now looks like candlesticks, and that's why it's called as the graph of the candles. Now if I plot y is equal to x on this curve, you can see that there are 3 points of intersection, and that is why the answer will be 3. Important point to notice here is only this: when y takes all values from y to 1 to 1.999, sine can be pi by 2. So this value can take all these things. So rather than a point, this works out to be a vertical line, right? And that is the reason why we get candlestick in the answer.